Welcome back to a new data science project. In this video, we are going to train a machine learning model for fraud detection, and we are going to build a Streamlit Web App for deploying our machine learning model. So we are going to be doing data analysis, training a machine learning model, creating a Streamlit Web App, and much more in this video. I'm going to be sharing the dataset that I used in this video. You can get the dataset from the link in the description. You can see the app that we are going to be create in this video from the screen right now. Let's start coding. Okay, we are in the data card of the dataset that we are going to be using for the fraud detection, and I'm going to add this link to the description of this video. You can just visit this link and use the download button at the right upper side of the page of the Kaggle for downloading the dataset for coding with me in this video. So what I'm going to do right now is I'm going to take a quick look at this Kaggle page, and then we are going to explore it more on a Jupyter notebook using Python. Okay. We have a fraud detection dataset. It says detect fraud on the go with a comprehensive dataset, and it says we have more than 6 million rows. Great. And it says some of these records were flagged false by existing algorithms, cachings. It says process of increasing the balance of account by paying in cash to a merchant. Cash out is the opposite process of cash in. It means to withdraw cash from merchant, which decreases the balance of the account. Debit is similar process than cash out and involves sending money from the mobile money service. And payment is the process of paying for goods or services to merchants, which decreases the balance of the account and increases the balance of the receiver. And on the transfer side, we have this is the process of sending money to another user of the service through the mobile money platform. Great. So here at the table we have the columns. I'm just going to take a look at them quickly. So we have step, type, amount, name original, old balance, new balance, and name of the target account, old balance of target account, and new balance of the destination amount. And we have the is fraud and is flagged fraud. So we have this fraud column in here, and we are going to try to predict that. Great. So again, you can use this download button for having the dataset, and you can just put that CSV file in the directory that you are going to create your Jupyter notebook and Python script. And I'm going to be recording on the code editor in a second right now. I'm in the VS Code, but you can use any code editor that you want. Firstly, I'm going to create a file like analysis and model.ipmb. We are going to start with a Jupyter notebook, and let's select our kernel as Python 3.11.4. In the next step, I'm going to create a code cell, and here's the data file that you are going to download from Kaggle AI machine learning dataset.csv. And I'm going to do my imports firstly. Like I will say import pandas as pd, import numpy as np. For the data visualization, we will import matplotlib.pyplot as plt, and also we will say import seaborn as sns. Also, at the first place, I want to set the seaborn's style as white grid, and also I want to import warnings, and I want to filter the warnings like warnings, filter warnings, ignore, like this. So after this, we can start to our analysis. Firstly, I'm going to say data frame, and it's going to be equal to the pandas read CSV, and I'm going to take the dataset name in here. Next up, I'm going to paste it in here. So after this, we are going to have our data frame loaded, and when it finishes, I'm going to just check by dataframe.head, and here we have our data frame. So once again, we have the steps, type, amount, name original, old balance, new balance, name destination, old balance destination, new balance destination, is fraud, and is flagged fraud columns in our Jupyter notebook right now. Great, let's start analyzing it. Firstly, I want to get a general information about the data types and also the memory usage side. So we have 5 floats, 3 integers, and 3 object types, and the memory usage is 134 in here. Okay, so I'm just going to take the column names here, and I will say data frame is fraud dot value counts for seeing the count of the fraud and non-fraud count. So we have the 8,200 frauds and 6,354,000 non-frauds. Also, I want to see the same statistics for the is flagged fraud. And I'm just going to make this run, and here we have a really low number on the flag side. Okay, firstly, let's see if we have any NA values in our dataset. So I'm going to call data frame is null, and this returns cell-wise booleans, but if we go with sum, it's going to return us the column-wise NA value count. And if we just go with sum again, we can see the general number on the dataset. Okay, we don't have any NA values. And let me quickly check the shape of the dataset. Here we have 6,362,000 rows with 11 columns. Okay, in this place I want to see the percentage of the frauds to the total data. So I will say data frame is fraud value counts, and let me see the output of this one more time. Okay, we are going to take the first index of this, and this is our fraud count, and we are going to divide it by data frame shape 0. So this is going to give us this number. So our percentage here is, we can multiply it with 100. We can add parentheses like this, maybe necessary, maybe not. I prefer using that. So fraud percentage we have in our data is 0.12%. And if we round it, maybe 0.13. Like maybe it's going to be clearer. We can do it like, let's say 1, and we are going to see, actually my bad, 2 decimals. Okay, 0.13. Great. So if we direct the model like this, we are going to have class imbalance. So we are going to handle that situation later on this tutorial. Firstly, let's analyze our data by visualizing the important things about fraud detection. I'm going to start with visualizing the transaction types. So data frame type, value counts, and then I will say plot. Kind is going to be bar. Next up, title, we are going to give a title like transaction types, and we can specify a color like I love sky blue. I will pass that. Next up, I'm going to say X label is going to be transaction type, and Y label is going to be count, and I will pass plt.show after that. And here we have our plot. So cash out is the leader, and at the left side you can see it says scientific access, payment second, and the last one is debit. Okay, now let's find fraud rates by types. So I will say fraud by type, and it's going to be data frame group by. I will pass type, and I'm going to go with the fraud. On the aggregation side, I will use .mean. Next up, I will say sort values ascending false. Next up, I will say fraud by type .plot. Kind is going to be bar, and title is going to be fraud rate by type. And next I will say, like, let's say color, let's use another thing like salmon. And next we can directly say Y label will be fraud rate, and we can pass plt.show. So here it is. So our fraud rate on the general is 0.13%, and here we can see the distribution. Transfer is leading, and cash out is the second place on the fraud rates type wise, and we can see nearly 0, maybe they are 0, cash in, debit, and payment. So let's quickly check if they are 0 or not. Okay, they are 0. Okay, it makes sense. Now let's go with the amount statistics. So I will say data frame amount, and I will pass describe like this. Next up, we are going to see we have scientific numbers. We can go like maybe as type and integer like this. Here we can see the numbers. The minimum amount is 0, makes sense, we have no negatives on that side, and the maximum is 92 million, and we can see the quantiles. So we have an outlier on this side. In my opinion, we have the mean of 179,000, and our standard deviation is large since the difference between these maximum values and the quantiles are large. Okay, now let's get the histogram of this. I will say seaborn.histogram plot numpy. I will use log transform for having a smoother histogram. I will say data frame amount. I'm going to pass bins as 100, and I will pass KDA as true, and I will pass the color of green. Next up, I will say title transaction amount distribution, and I will pass log scaled, and let's say like maybe log scale is better. plt.x label amount plus 1, and I will say plt.show. So here we are going to have our histogram in a second with this code. We can see our histogram in here, and we can see the scale. Great. Next up, let's look at the relationship of the fraud and amount. So I will say seaborn box plot, and I will say data frame. I'm going to filter the amount, which is going to be less than 50,000. And I will say X is fraud. And next up, I'm going to say Y will be amount. And we can give it a title like amount versus is fraud. And we will say filter it under 50K. And I will pass plt.show. And we are going to have our plot ready. Here it is. So from here we can see that for the higher amounts which filtered under 50K, we have more fraud rates and the lower mean on the non-fraud side, closer to 10,000. Okay, let's see the balance chains and the anomalies. So firstly, I'm just going to create two different columns as balance difference of the original account and destination account, and I'm going to try to see if we have any negative balances on that side. So firstly, I will say data frame balance difference original and data frame old balance original minus data frame new balance original. Next up, I will say, actually it will be let me quickly check the column names here. Okay, we have this. Next we are going to have this the same for the destination. We will say data frame new balance destination minus data frame, I will say old balance destination, like this. Okay, so now we can check if we have any negative values on that side. I will say balance diff original, and we can go with closer. Actually, let's not take the values closer to 0. I will directly pass that, and we are going to have a Pandas series like this, and we can just take this into parentheses and we can pass some like this. So we are going to have, we have a lot of balance differences with a value less than 0, which means negative on the original side. That's interesting. Let's see this for the destination. So I'm just going to copy this, and I'm just going to change this like here. I will just pass destination, and we can see that we have a lower value, but this is a big value again. Okay, so in the data, I will just call data frame.head. We have a column named step, and it's increasing by day. So I'm just going to create a plot, then I'm going to drop the step. So I'm just going to prepare the dropping code. I will pass columns, and I will take the step, I will set in place equals to true, so it will modify the original data frame. And after visualizing number of frauds with step, I'm going to drop the column. So let's do that. Frauds per step is going to be data frame. Data frame is fraud equals to 1, and I will take the values of step. I will use value counts, actually lowercase letters. I will take the value counts and I will say sort index like this. Next up, I will use plt.plot and I will say frauds per step like this, and I will use index. Next up, I'm going to say frauds per step dot values, and I will say label is going to be frauds per step, and we can customize our plot like x label is going to be step, which means time in our data frame. Y label will be number of frauds, and title is going to be frauds over time. I'm going to set the grid as true, and I will use plt.show like this. So here it is. Actually, it seems non-time dependent. Okay, we are not going to use the time on this side on the modeling. So I'm just going to drop that, and when I call data frame head, we are not going to see the step from now on. Great. So let's go customer wise. I want to find the customers which makes the highest amount of transactions, like the top senders and top receivers. And firstly, I will start with top senders, and it's going to be name. We are going to go with this column. I will use value counts, and let's take the top 10. So in the top sender side, and we have this, the 3 generally. Let's see if we have an equality on the top receiver side too. Top receivers, it's going to be data frame name destination value counts head of 10, and after that I'm going to say top receivers. So we don't have an equality on this side, and customers wise we can see that who takes the highest amount of transactions. So let's see the fraud making customers. I will say fraud users, and I will face data frame. Data frame is fraud. Of course, we are going to filter this as true, which means 1, and I will pass name original value counts, and I will take the top 10, and I will take the fraud users like this. Okay, we have equality on this side. Great. Let's analyze the transfer and cash out, because in our plot, let me quickly go to that, we saw that these 2 transaction types are the most open ones for the fraud. So let's just come here, and I will say fraud types, and it's going to be data frame type is in, and I'm going to pass the list as transfer and cash out like this. So after this, we are going to have fraud types data frame like this, which has on the type side only 2 values. Like, let me quickly show you. Type value counts, we are going to have cash out and transfer only, and we can create a count plot on this, like seaborn count plot. Data is going to be fraud types, X is going to be type, hue is going to be fraud. Next up, I'm going to give the title fraud distribution in transfer and cash out like this, and I will use plt.show after that. So we are going to see this distribution in here. Okay, since we really have a low fraud values, we can't even see the orange, but we can see cash out dominates this chart. Now we can go with a correlation matrix. So we are going to filter the numeric columns like data frame, amount, and old balance original, new balance, original. Next we have old balance, destination. We have new balance, destination, and we have is fraud. And I'm going to say, like I got one in here, I'm going to delete that. I will say dot correlation like this, and I'm going to make this run. Now on the correlation side we are going to have a matrix like this, and we can visualize it using a seaborne heat map. I will say seaborne heat map. I will pass the correlation matrix we have, and that will be true. I'm going to set the color map as cool warm. Actually I will pass like CMap cool warm, and next up I'm going to say to floating, like I'm going to format it like this. I will say plt.title, and it's going to be correlation matrix, and I will use plt.show. So let's see our correlation matrix. Here we can see the high correlations in our data. The ones are the intersection of the same column, and we have 0.98, which means high correlation between new balance destination and old balance destination, which is kind of normal. And we have like new balance destination and amount correlation of 0.46, not that strong but not that weak. So just for a recap, correlation can take values between -1 and 1, which -1 means strong negative relationship, where 1 means strong positive relationship, and 0 means they don't really have relationship. Now that's strong one. Okay, now I want to filter the customers who has balance, and after the transfer they go to 0. So I will say 0 after transfer, and it's going to be data frame. We are going to add 3 filters on the side. Firstly, data frame old balance original is going to be greater than 0, and data frame new balance original equals to 0, and we will say data frame type is going to be isin, actually like this, transfer and cash out. So we can just say 0 after transfer. We can take the length of this for seeing the customer amount like this. Here we have more than 1 million. These records, like this list, is just the suspicious records, and we can check them if we want to find their registration. Great. So now we are going to get the feature engineering, but we have an important thing that is fraud value count. We have a class imbalance situation. So for that, let's do feature selection and preparation. So we are going to make some imports from Scikit-learn. We will say Scikit-learn model selection import train test split, Scikit-learn preprocessing import standard scalar, Scikit-learn linear model import logistic regression for the modeling side, and from Scikit-learn.metrics import classification report with confusion matrix, from Scikit-learn.pipeline import pipeline, from Scikit-learn.compose import column transformer, and from Scikit-learn.preprocessing import one hot encoder. Okay, so these are going to be our imports, and in here we are going to use train test split for splitting our data into training and testing sets, standard scalar for scaling our data, logistic regression for the modeling side, Scikit-learn matrix classification report and confusion matrix. These are for model evaluation, pipeline for training the model and doing the transformation operations together, column transformer, one hot encoder for the data transformation. So I'm going to call data frame.head again, and we have type, amount, name, original, old balance, original, new balance, original, name destination, old balance destination, new balance destination is flagged fraud, balance difference, original balance different destination. So what we are going to do is, firstly, we are going to drop some columns. Data frame model, we will say data frame drop, and I'm going to drop name original. I'm going to drop the ones that I'm not going to use on the modeling, name destination, and is flagged fraud. And I'm going to set the axis as 1. So I'm going to make this run, and let's see the data frame model head. Okay, it seems great. Next up, we are going to set the categorical and numerical types. Like categorical is going to be type, and only this one, and numeric is going to be amount, old balance, original, new balance, original, and old balance destination, and new balance destination. Okay, seems cool. Now I'm going to set the target. Y is going to be data frame model target, is going to be is fraud, and X is going to be data frame model dot drop. We are going to drop is fraud like this, and axis is going to be 1. Okay, so it's going to be capital X. It's the general usage. I will use it like this too. Now we are going to make train test split. X train, X test, Y train, Y test. We will use train test split. We will pass X, Y, test size of 0.3, and stratify Y. So in here we set the 30% of our data into testing set and 70% in the training set. Like X train and Y train holds the 70% of the data, and X test and Y test holds the 30% of the data. Next up, we are going to do preprocessing. So we will say preprocessor, and it's going to be column transformer. We will pass transformers, and I'm going to give a list. Like for the numerical ones, it will use standard scalar. I will pass numeric 2. Also, I need to use parentheses for the correct initialization, and for the categorical, we are going to use one hot encoder, and I will say drop first. And also what I'm going to say is categorical, like we defined. Next up, I will say after this remainder drop, and after that we are going to create a model pipeline. So let me fix the typo firstly. Transformers. Okay, now it's cool. Now we are going to create the model pipeline. So I will say pipeline, and I will use the pipeline class for the Scikit-learn, and preparation, preprocessor, and classifier is going to be logistic regression. This part is really important. We are going to set the class weight as balanced because we want to handle the class imbalance situation. Like 99% of our data is not fraud, so our model is going to predict non-fraud for every input we pass if we don't set this class weight to balanced. We are handling the class imbalance situation in here, and after this I'm going to say max iterations is going to be 1000. So next up, actually parentheses need to be at the end like this. Okay, next up what I'm going to do is I'm going to train my model with the preprocessing. So we will use pipeline.fit, and I will pass X train with Y train. So when I do that, it's going to train the model, and I'm going to be re-recording when this finishes. Okay, our model is ready. Here we can see the pipeline steps, standard scalar, one hot encoder, and logistic regression like this. So we can make predictions using .predict method right now with our machine learning model. So we can say predict, and we can pass xtest, and we are going to have a prediction array like this. So I'm going to save them like y prediction, and I'm going to compare with the y-test right now. I will say classification report, I will pass y-test and y predictions like this. So I will also pass print. It's not looking pretty. Now it's going to be better like this. Great. And we can also get our confusion matrix on our model, y-test, y prediction. Here it is. True positive, true negative, false positive, false negative. Okay. So in here we can say that our model is good on catching the frauds and precision is not that good. In here we can just do like try other methods for class imbalance like smooth or undersampling type of things, or we can try different models, but I'm not going to do that. I'm going to use this model. It's okay for me and it can be used in my opinion like pipeline.score x-test with y-test, and we have the 4% accuracy and I think it's pretty cool. I'm going to continue with this model. Again, we can improve this precision, like it's going to be better 100%, but I'm not going to make this video too long, but you can go with the methods that I shared for fixing this situation. But for this tutorial, I think it's going to be more than enough of this % of accuracy. Great. Now, it's time for exporting this pipeline. So we will say import joblib at the first place. And then we are going to say joblib.dump. We are going to export the pipeline and we can say it like fraud detection pipeline.pickle. And here in my file directory, I don't have a pickle file like this. And when I make this run, we are going to have fraud detection pipeline.pickle in here. And we are going to be using this for getting predictions from our model in our Streamlit app. So let's summarize what we did in here. Next, we can move to the Streamlit app creation. Firstly, we imported Pandas, NumPy, Matplotlib, and Seaborn. Then we load our data and we did some analysis and we did some data visualization and analyzed the data set like this with different chart types. And after that, we have a correlation matrix in here. Next up, we started to do feature engineering at the first place. We made our imports, column transformer and one-hot encoder on the transformation side, pipeline for creating a data pipeline with preprocessing and modeling, classification report and confusion matrix on the model evaluation side, logistic regression on modeling side, standard scaler for scaling and train test split for data splitting. We selected the features that we are going to be using in the model. Then we defined the columns with their data types like this and we saved X and Y to target. And we used train test split with the 0.3, which means that 30% is going to be in the testing set. We set our column transformer for numerical and categorical. Next, we set our pipeline and trained our model. We get predictions and we evaluated our model. At the end, we exported our pipeline and we are ready to create our web app. So now I'm going to create a file like fraud detection.py and we are going to create our web app for using our model in here at the first place. So at the first place, we will say import Streamlit as st, import Pandas as pd, and import joblib. And we are going to load our model, like model is going to be joblib.load. We will say fraud, let me copy the exact name in here. In here I'm going to copy this and paste it in here. So now after we load it like this, we can just say model.predict and it's going to be working on new predictions. So let's set a title for our Streamlit app, fraud detection prediction app. Next up, I will say Streamlit markdown and please enter the transaction details and use the predict button. Next up, I will say Streamlit.divider for a better look and I will say transaction type is going to be our first input, and it's going to be Streamlit select box. We will say transaction type, and we are going to pass transaction types like payment, transfer, cash out. Actually, they need to be uppercase, like payment, transfer, cash out, and also deposit inside the list, like this. Next up, we are going to set the amount, and it's going to be Streamlit number input. We will pass it like amount, and we are going to say, let's say minimum value is going to be 0.0, so we will take float as input, and let's set the default value as 1000. Next up, I'm going to take old balance original, like this. Streamlit number input, old balance, and I will say sender. Next up, I'm going to say minimum value is going to be 0.0 and value is going to be 10,000, like this. Okay, next up, I'm going to say new balance original, and it's going to be Streamlit number input again, new balance sender, and we will say minimum value, let's say 0.0 again, and value, let's set this to 9,000. Next up, what I'm going to do is we are going to do the same for the old balance destination and new balance destination. So old balance destination is going to be Streamlit number input. We will say old balance, and I will pass receiver. We will say minimum value will be 0.0 and value is going to be, let's say, 0.0. Also, we are going to make a last one. New balance destination is going to be Streamlit number input. New balance receiver, we will say minimum value is going to be 0.0, and let's set the value like 0.0. Okay, so now we are going to define the prediction button. So if Streamlit button, which means that if this button gets clicked, I will say like predict, and we will say like input data is going to be Pandas data frame. We will pass a dictionary inside a list like in here, and we are going to say type is going to be transaction type, amount is going to be amount, and old balance original is going to be old balance original, and we are going to do the same for the new balance original is going to be new balance original. We will say old balance destination is going to be old balance destination, and new balance destination is going to be new balance destination, like this. So here is our data frame is ready, and now we will say prediction is going to be model.predict input data, and we are going to take like the first index. This is going to return 0 or 1. So we will say Streamlit subheader, and we are going to say f-string prediction, and it's going to be integer prediction, like this. And we can say like in here 0 means, actually let's not go for that. Next up, we will say, this is going to be better, if prediction equals to 1, streamlit.error, this transaction can be fraud, and else we will say Streamlit success, this transaction looks like it is not a fraud. And here it is. Great. So we are going to save this Streamlit file and make this app run. Then after showing you how this app looks and how it works, I'm going to summarize the code in here. So let's go to the Streamlit. I'm going to open the terminal, and from here we are going to say Streamlit run fraud detection.py, the file name that you just set it when you are creating your Python file. And when you press enter on that, oh, we got a typo. Let me quickly fix that. In which one? Old balance, original, okay, mean values. Now it's going to be saved, and I'm just going to open new one, Streamlit run fraud detection.py. Now it's working smoothly. Okay. In here, a Streamlit page is just opened in this address local URL. You can just use Control or Command plus click, or you can just copy this address and paste it on your browser. You are hosting this app on your browser right now. So just go to this address, and I'm going to be re-recording on my browser right now. And here I am at the Streamlit page, and I'm just going to set this to dark mode quickly, like this. And now we can test our app. So we have fraud detection prediction app, and here transaction type payment, and amount. Here we can see the values. I'm just going to try the predict with the default values. Here we see that it says this transaction looks like it is not fraud. So let's make the new balance as 0 and increase the old balance like this, and let's see the result. It's not a fraud again. Okay. Our model is doing a great job on predictions. So let's say that we are going to do cash out, and amount is going to be 1000. Let's keep this, and I'm just going to make this a huge number, and I'm just going to save this as 0. So when I say predict, it says prediction is 1, a fraud detection, and it says this transaction can be fraud. Okay, it's working nicely. Let's also see this on the transfer side. I will say predict, it says this transaction can be fraud. Amazing, great. So let's make another example. Payment, I will say 5000 in here like this, and I will say 10,000, and I will say 5000 on this, and let's see our prediction. It says this transaction looks like it's not a fraud. So our model and our web app is working really good. I'm going to be recording back on my code editor right now. So here on the Streamlit side, we started with importing Streamlit, Pandas, and Joblab. Then we loaded our pipeline in here as model. Then we give our app a title, and we wrote a markdown as please enter the transaction details. Actually, there was a typo. I'm just going to delete that. Doesn't matter. We take the inputs from the user in here. One select box for the categorical, the others are number input. And we define Streamlit button, predict, and in here we just set the input data like this in a data frame. Then we pass this into model.predict and get the prediction with this. Next up, we write the prediction and we display this is a fraud or not. That was it for the coding part. Let's get to the outro. Thanks for watching this tutorial. I have a playlist named Data Science and Machine Learning Projects where I have more than 40 videos just like this one. You can reach to that playlist from the cards of this video or from the links in the description. Also, I'm sharing a new data science video every week on my channel. You can subscribe for more videos like this. Have a great day.